Okay, in this video, we're going to talk about what is a logarithm, or just logs for short is what we usually just describe them as. So a logarithm is really nothing more than just a way to express our answer when we're solving an exponential equation. So for example, 2 to the x equals 8, most people don't really need any fancy logarithm to just look at that and know that what power of 2 gives me 8. Well, x is just going to be 3, right? 2 to the x equals 16. What power of 2 gives me 16? Well, if 2 to the third is 8, I multiply by 2 one more time, that gives me 16. The answer would just be x equals 4. So no big deal there, no need for a logarithm. Where a logarithm comes in handy, though, is what if I had, I'm going to write it in between here, what if I had this exponential equation? 2 to the x equals 15. Well, I know that there's a power of 2 that gives me 15, and I know that the answer is going to be between 3 and 4 because 2 to the fourth was 16. So I know this answer is probably going to be slightly less than 4, but how do I express my answer, right? If I don't have a calculator. And so this is where logarithms come in handy. The way we express our answer is we say x is equal to the log base 2 of 15. I'll write this out. Log base 2 of 15. Right? This is how we would express our answer. And in fact, back to these two that we just knew the answer, I could have written this answer if I wanted to. 2 to the x equals 8. I could have said x is equal to the log base 2 of 8. And you kind of get a sense of what this means then. What the log base 2 of 15 is it's the power of 2 that gives me 15. I'm going to write that down as well. This is how we read it, but what it really means is the power of 2 that equals 15. Log base 2 of 15, that's exactly what it means. Okay, and same thing here. We could have written that in terms of a log. But let's look at some other examples. So they're really, really useful when you have an exponential equation where the answer is not nice. 3 to the x equals 11. Well, I know there's an answer there. I know 3 squared is 9. 3 to the third is 27. So I'm expecting my answer to be a little bit bigger than 2. How I would express my answer, though, for x is I would say x is equal to the log base 3 of 11. The power of 3 that gives me 11 is how I would write the answer. And one thing that's kind of helpful, the base, when we say the base, that's the number we write smaller down below. If you go back to your exponential equation, I think of a base as something that holds up, like the base of a building, right? It holds up the top. And so you can kind of think of this 3 as the base of your exponential equation as well. And it's the base of your log. So it's one way to get them straight. You can even take something more involved. If I had 4 to the 5x plus 6 equals 7, as using this as a model, our exponent, which in this case is the whole entire 5x plus 6, would be equal to the log base 4 of 7. And once I write it like that, it's easy enough to solve for x. I could subtract 6 from this and then divide the whole thing by 5. I could say x is equal to the log base 4 of 7 minus 6 divide by 5. Now, for certain exponential equations, if I have 10 to the x equals 5, I could say my answer for x is log base 10 of 5, which is totally fine. But base 10 is very, very important. Our number system is base 10, right? If you think about it, you have your hundreds, which are 10 squareds. Your thousand is 10 to the third. 10,000s, 10 to the fourth. A million's 10 to the sixth. So our number system is base 10, and we use that a lot. So in terms of logs, log base 10 is a very common base to use. We call this a common log. And so you could also express this as just x equals the log of 5. In other words, you don't have to write the base. If you don't write a base there and you write log of 5, it's understood that your base is 5. So either one is fine, but this would be how you would see it more often. If it's base 10, just leave the base off. I think of it as the same thing as like with radicals, right? If you want to tell somebody to take the cube root of a number, you have to put a 3 there. If you want to take the fourth root of a number, you have to put a 4 there. If you want to take the square root of a number, technically there should be a 2 there, but square roots of all your roots, those are the most common ones. So we just leave it off, right? We just make it the square root of x. It's kind of the same idea in my view of things. Another important base for a log is e. And if you're not familiar with e, the number e, you will be as you go into calculus. Arguably, everybody gets all into pi, and pi is a very cool number. But I would argue when you get to calculus, e is even cooler. You don't find out all the neat things about the number e until you delve into calculus. So for now, I'm just going to tell you, you will see more about this number, but e is a number that is approximately 2.718. As a very rough approximation, you could just say 2.7, or I even just say just slightly less than 3, right? If you really want a rough approximation. If I had, so this, you could read this as like 2.7 to the x equals 3, right? Something close to 2.7. So if I were to solve this for x by writing it in log form, I would say x is equal to the log base e of 3. If you write it like that, that's totally fine. But kind of like with log base 10, you're going to be using log base e's a lot in calculus. And so we have another notation, shorthand notation, which is, I'm going to write this as a cursive L, the natural log of 3. That's an L. ln of 3. It's the natural log of 3. That's how you would read that. So when you see an ln, then you know there's an invisible base e that's not written there. That's your base. Totally different look, but they mean the same thing. So kind of to summarize this for this video, if you've got any exponential equation, b to the x equals a, we know now that you could always write this as x equals the log base b of a, and these are equivalent. You can go back and forth, and what we'll see on future videos, you know, here I've been taking the exponential equation, writing it as a log, but you can take a log and write it back as an exponential equation as well. And we'll do lots of that in the future.